My name is Christophe Binetruy. I'm professor at École Centrale de Nantes. I'm doing my research in an Institute of Research in civil engineering and mechanics. My field of research is composite materials, where my main focus is modeling the composite manufacturing. I'm responsible for a chair dedicated to a composite for automotive industry, sponsored by a company, it's a T1 supplier, is Faurecia.
So I'm full professor at the École Centrale of Nantes in the Institute of Mechanical Engineering, and I'm working in the field of advanced numerical simulation of materials and processes. I was for 4 years titular of a chair from EADS, and recently I was nominated titular of a chair from ESI. The main aim of the chair is developing advanced numerical simulation in order to focus in new materials and new process. When you are treating composite materials and you are simulating manufacturing process, there are many challenges because this kind of materials are complex, are multi-scale, and the physics involved in the process are different, and this implies a kind of couple multi-physics problems. So the dream for industry is solving real problems very accurately and solve these problems very fast, and if possible by using a smartphone or a tablet. So this is the challenge. Is possible or not to address real problems encountered in industry by using very small platforms and compute these models very accurately in real time. In our group at the École Centrale of Nantes, we have an expertise that concerns the very fast simulation of material and process. Because by using model order reduction models, we can solve many models that are found in the industry, even in real time. We can solve these models in real time, and we can solve this model by using quite light computing platforms. And for us, it's very important that all the tools that we are performing be transferred to the industrial practice. And from this point of view, I think that ESI is the best choice.
Actually, there are different programs with ESI. We have, for example, a research dedicated to analyzing the effect of non-Newtonian fluids in the filling of molds filled with fabrics. So the main question is, how can I compute the effect of this non-Newtonian behavior at a reasonable cost in terms of computational time? And this actually use the work by PACO, where we try really to provide at the end a kind of methodology where at the end engineers can afford to do this very highly demanding computational exercise. This is one example. I have another example in mind. This is a very new program we decided to kick off with or implement with ESI. Is we stay in the field of composite manufacturing, and we want to be able to address the very high reactivity of polymers. And this is a very key question for automotive companies, because they need to shorten the cycle time, so they use very reactive polymers. So in this situation, usually you have to combine different physics on chemistry problems. And at the same time, since I am involved in this chair with Faurecia, we decided also to have a kind of cross-fertilization of both chairs, because to try to create a bridge between both programs. And the common link is computational tools. So it's a kind of natural cross-linking between the chair with ESI and the chair with Faurecia.
The ESI solutions is a very nice compromise between the very high level scientific advances, because we are integrating, or you are integrating the best numerical approaches in your codes, and at the same time you are applying this and you are transferring this for solving the real problems that are encountered in industry. And this is for me quite interesting, and is not usual for other numerical solutions.
ESI is the main actor in this area. You have to keep in mind that the science dedicated to composite manufacturing is very new. It's a brand new science. I would say that started roughly 20-25 years ago. ESI is really a pioneer in this area, because I mean they understood that they have to really provide some solutions to the company very at the early stage of the development, and they started to bridge some links with universities and people from academia, and so they really make strong effort, because I remember that this period of time it was difficult because the knowledge was very limited, and during the time they built very strong solutions, and their codes are very good reputation in terms of the content. I think they are scientifically funded, and so I know that's why we really decided to have this program with ESI, and that's really the strength of the company, I think.